Hey guys, welcome to DOC Explained. Let's go over question number 26. If you guys want to read it to yourselves, go ahead and pause, otherwise we're going to jump right into it. Okay, crossing over between non-sister chromatids during meiosis is significant in heredity. This process most likely leads to an increase in which of the following? Okay, so let's highlight some stuff first off. Okay, if we understand these three things that I just highlighted, this question will be a piece of cake. So here we go. First off, meiosis. What is meiosis? Well, it sounds a lot like mitosis, and most people have heard of that, but meiosis is cell division. It's cell division in specifically sex cells. So it's cell division that leads to making sperm cells and egg cells. Now, why does sex cells have their own kind of like special cell division? Well, that's because in sex cells, you want to have half the number of chromosomes. They actually divide twice. So let's say your normal cells, your skin cells, maybe you cut yourself or maybe they're just dividing. They form, they divide once, they get all the information, they divide once, so you have two fully equipped copies of your cell. Well, with your gametes, with your sex cells, you want copies of them, but you only want them to have half the number of chromosomes. Now, why would you want your sex cells to have half the number of chromosomes? Well, you'd want them to have half because they are intended to be combined with another gamete of the opposite sex to form the baby, right? So that's why it has its own specific type of cell division. Okay, heredity. What is heredity? Heredity is just passing on of genetic information. Okay, and the last thing that really is going to pull this whole question together and help give us the answer is crossing over. What in the world is crossing over? Well, during cell division, during meiosis, crossing over exists. So let's look up the definition first off. All right, here we go. Involves the exchange of chromosome segments between non-sister chromatids during the production of the gametes. Remember, that's the sex cells. The effect is to assort or shuffle the alleles on the parent chromosome so that the gametes carry any combination of genes different from their parents. So it's essentially shuffling them around. All right, so real quick, alleles. What's an allele? Well, an allele is, if you've ever done a Punnett square, allele is just the specific letter. So when you see one letter, that's an allele, right? Okay, so it's more or less shuffling around. Let's look at another picture to help give us, an illustration of what we just saw. All right, so you see the crossing over. You have, the chromosomes. They're kind of sideways here. They crisscross. It's almost like they're holding hands. And then the outcome of that is they shuffle up the genes. So you can see the mismatch of color. That's trying to show you that, the genes are mixed around a little bit. So it's essentially like you're shuffling the deck of a card game, right? So imagine if you played cards. The game used every card all the way back to the front, the very first card, and then the next game you never shuffled the deck. Every card game would almost be the exact same. It'd be a very boring, very boring card game. Well, that's pretty crappy. So yeah, crossing over happens to keep everything mixed up. So it's like shuffling the deck, right? So let's rewind a little bit because we just went through a whole lot of stuff really fast. All right, let's look at F real quick. Why does crossing over take place? Most likely leads to an increase in what? All right, F says increase in the number of expressed dominant traits. Well, it actually doesn't increase the number of expressed dominant traits because if it did, then most of the cells made after you combine the gametes would have dominant traits. So you'd see a whole lot of people with very similar traits. So let's say out of 1 million people, 900,000 of them would have black hair. That's not good. That's not good for variety anyway. So no. Let's get rid of F. Okay, let's look at G. Increases the number of gametes. Well, no, again, you just want a sperm cell and you want an egg cell, and those combine to form a baby, right? So the gametes don't really increase. So let's rock and roll and get that out of here. Okay, increases the occurrence of polyploidy. What in the world is that even a real word, or they just make it up for this question? It actually is a real word. Polyploidy, we know poly means like many. So normally you have a pair of chromosomes, just like that, just like this, right? With polyploidy, instead of having one pair, you might have like 3 pairs. So you have a ton of chromosomes stacked. So it's not just having one extra one. So instead of having a pair, you might have 3. It's actually having like 6 chromosomes, 3 from mom, 3 from dad. that's generally very bad, right? So we don't want to increase the number of chromosomes. So polyploidy, no, not a good answer. Genetic variation, that is the best answer. So if we go back to our original slide, we can see that it mixes things up a little bit, right? It gives some differences, and it gives some variety. And variety is good for a number of reasons. You know, most people like variety, but as far as like a evolutionary reason, think of like this. Think if we had 1,000,000 people, right? And they're all exactly the same. Guys and girls, just about the same genetics, right? And let's say there's a new disease that happens, a new disease that comes around. And this disease, nobody's ready for. And since there's no variation in people's genetics, these people are susceptible, and when they get hit with this disease, it wipes everybody out, right? Because everybody gets hit by it. There's no variation, so nobody has any kind of mutations that prevents them from getting this disease. So they're done, wipes everybody out. Well, when there's variety, that doesn't happen. So maybe there's a new disease out of this 1,000,000 people. Maybe it wipes out 800,000 people, almost 80% of everybody, right? Wipes them all out. But there's still a little bit of people left because they have some variety in their genetics to avoid getting wiped out, right? There's actually some people, a set of people, Eastern people, that they are essentially immune to AIDS, because AIDS have to have a way to get into your cells, and most people have markers on the outside of their cells, and that's how the AIDS virus, or the HIV virus will get into cells, right? Well, they don't have those markers, so the HIV virus, they can't get into their cells. So that's a mutation that these people just so happen to have that essentially makes them immune to the HIV virus. So variation is good. Therefore, crossing over is good. It helps everybody, and it provides a little bit of variety. So with that being said, we'll mark out all our answers. We got genetic variation is what is increased with crossing over. Have an awesome day.